really need to introduce myself as David's done that. But just like a very brief one, I work as the principal data scientist for HSBC, and I'm designing their ML stuff for the global banking and markets division. I also founded the Women in Machine Learning Data Science for London, as well as the Women Ambassador and Women Tech Makers. I love promoting machine learning for minority groups. So if you are someone that represents a company who would love to host talks or machine learning tutorials, mentorship activities, then do feel free to reach out to me. I love organizing and promoting these things for the people in London and globally. Now that we're all virtual, everyone can attend. Just where to find me on LinkedIn if you want to know more about our organization. But without further ado, let's get back to the topic in hand. So, machine learning in production. I've been lucky and fortunate enough to see how machine learning has evolved in this almost a decade. Makes me feel old, but it is what it is. And really, let's think about what machine learning used to be 9 years ago. It was just us having a set of data. It wasn't that big data, so it could just work on our computers, and that was great. You derive some features from it, run a model, you have predictions, and everyone's happy. And a simple thing like that can easily work on Jupyter notebooks. But that's not scalable. And what happens when this company starts growing? So when I was in a startup, this setup worked for maybe the first few months. And then and this was in advertising. And as the number of clicks grew, the number of impressions grew, our models would take more than 24 hours to run on some SQL Server machine. And we realized we're not a small company anymore in terms of data. We've moved very quickly to a big data domain. Data started growing from terabytes to petabytes, and then suddenly you have to go to the cloud or have on-prem machines. And having models that you can rely on, that you can deploy with proper streamlined procedures in place. And hence you're no longer in that experimental machine learning domain. That's when you start thinking about moving towards, okay, what does a production system look like, and how can I use this in machine learning? And this is something that is still developing. A lot of companies still don't have this. A lot of companies wouldn't be focusing on the entire life cycle. They would only focus maybe on the training part. But really, there's a lot of focus from that needs to be put into the data part itself, like the data ingest part, and then moving on to the monitoring and the tracking part, and then repeating this and constantly being aware of the fact that data is not static and that the distributions are constantly changing. So what does this production machine learning system look like, and what are the various components of it? And I know that most of you are hopefully familiar with machine learning and the various parts of it, but you all care about production, and really that's why you're listening to this talk. Otherwise, there's no point. But there are so many important aspects that we need to pay attention to. And this is something that I feel that has to be repeated in every organization you go to, because generally I'll find 4 or 5 components missing from this pipeline. So I really actually want to spend around 5 minutes going through this. And let's just start from data. Going from a small organization to a really huge global organization like HSBC in almost 64 countries, I've really seen bad data. And every time I think that it cannot get worse, it does. It's pretty amazing on how horrible data can be. So having proper processes that maintain and take care of that data that you're ingesting is so important if you're putting something into production. Obviously, when you have something in production, you've already gone through this phase, but if you don't have processes around it, you won't know which parts failed, and then that can propagate in your model, and eventually it's really hard to track back to where something worked and where something didn't work. So I would, when designing something in production, I go back to as far as ingestion. For me, ingestion is really important, especially in large organizations, because your data is being ingested from various countries, which are in different formats. Those ingestions might not actually have the same sort of unit testing globally. And in that case, you might have an issue where if you're ingesting something country-wise, and on the same day, even that is sometimes challenging because you might not get the same day for different countries. But when you do, you might have missing data for certain countries, and then suddenly you have gaps in your ingest that might not go noticed because the unit test might not have covered that. And that might be really important if you actually want to map or predict behavioral changes per country. Then let's go to data quality. The data quality, I cannot tell you how important that is. For me, if you're designing something, any system in production, data quality is what you need to first pay attention to. It's a garbage in, garbage out process. If you're putting garbage in your model, it's not going to come up with magic. It's not magic. So you definitely need to make sure that your data quality is on point. Then comes the part of data cleaning. So once you've done that initial DQ, you know what part's missing, you know what's badly formatted, and you know what needs to be more uniform. Some places could have country in a two-code place, so two-letter codes, and some people have countries in a three-letter code. And if you're doing some sort of encoding, categorical encoding, or let's say embedding, which is what I hope you would be doing if you have a country encoder, then in that case, that's suddenly double the number of countries that you had, and that's incorrect. So you need to make sure that transformation is done in that data cleaning stage. Then comes the EDA and validation. Now you would think that this should go more in the feature stage, but actually I think it fits both in both stages. The reason why is because in a small organization, it's not that crazy to join up those databases because you don't have that many tables and it's nice. In large organizations, you could have a database, you could have almost 1,000 databases. Each of those databases could have 2,000 columns, 2,000 tables, and each of those tables could have 1,000 columns. And this is speaking from experience that even those columns could be really badly named and you wouldn't even know what you're joining. So you need to then contact an SME for that database, for those tables, to then help you validate that this sort of structure that I have for my data, the data frame that you're producing for your feature derivation is the right structure. And then once you have that right structure in place, you need to aggregate that. Now, all of this thing has to be done constantly because you are going to get data constantly. So if anything is as consistent, then it needs to have a process around it. It has to be have CI/CD integration and deployment around it. And you need unit testing to ensure that all the changes have been tested and that pass, and all of this goes downstream in the right way. So that's and also a lot of logging, obviously, because you always want to monitor what's gone wrong, why something failed, and at what stage. So that's just data, and you can already see that this is way beyond any notebook that can handle things. So then you come more to the feature side. Now, from the feature side, you have imputation, and this can be something as simple as just putting zeros, or it could be that you want to use a GAN imputation, which is called GAIN, which is like the newest way of how you can impute features and not just take averages or medians, which can easily skew your distribution. Now, that itself is a whole machine learning model on its own. And that needs to be run as a process that starts after the data part has been finished. So then you need a scheduler to basically fire the feature imputation every time that data column has been filled in, right? And then after that, you have the feature transformation stage. This is stuff like encoding. So you want categorical features and numerical features. And you also want to have things in place which are storing your feature artifacts. Now that's a new one, right? You always hear model artifacts. Well, feature artifacts are important because a common mistake that I see in a lot of organizations is that when you're scaling, you're encoding your data, the objects should only be fit on your trained data. They should, and then transformed on the train validation and test. When you don't do that, that means that you're introducing leakage. And in order to not do that, you need to save those objects. It gets even more complicated when you're doing cross-validation, because at this point, with cross-validation, each of those folds has a training set of its own, which means the encoders and that pipeline that you create to do the transformation has to run for each of that training fold, and each of that has to be saved. So now it comes to things like the paths need to be right, that objects need to be saved correctly, you need to transform the right data with the right object, all of that needs to be tracked and version controlled. So there's a lot of things about optimization, space storage that needs to be thought about. And then obviously the feature validation and selection. So making sure that the feature you're using is actual, the data in that feature is what you would expect it to be. The distributions to look normal. There's not like some nans that escaped or some weird formatting of some country that's not really a country that entered that feature. So you want to go through the distributions of those features and make sure that's correct. you want to probably do something like PCA or something to do feature selection, because you could have, if it's just 5 or 10 features, great, you could just do feature importance and go with that. But if you have 1,000 features, you probably do want to do some feature selection around it. And again, you would be thinking that, okay, but I'm putting a model in production, I've already done that. But that's not that simple, right? Because like I said, data is not stationary. You're always going to have new features. Your distribution is going to change, which means all of these things have to be repeated. And what you've done is you've tested that initial stage, but in order to keep your model running and be consistent, you need to constantly check for all of these things. So that gets us to the modeling stage. Now, with the modeling stage, obviously that's the core of why we have this whole production process here. So you want to think about model train. And what I mean by that is not training your model, but when and how often do you need to train that model? That's really important because it depends on how often your data changes and how often your distribution of the underlying distribution of your features changes. And if that changes, then you need to do the model tuning again, because your hyperparameters will change and that needs to be tuned, refit to the new distribution of that model. Model decay is a thing that would generally happen when your distribution has changed and that model might not perform the same way. The way to track that is then towards model evaluation. So model evaluation is when you're going and looking at your evaluation metrics. You want to ensure that if on average my model has an ROC of 0.8, then is that still the case or has that changed? And if that has changed, by why? So those are the things that should be flagged. So you want to make sure that you have model monitoring and validation in place where you're constantly flagging these things to the right people and ensuring that the quality of the model doesn't fail. And then there's also model tracking. Model tracking is really interesting both from the non-production stage as well as the production stage. The non-production stage is really great because you can do things like vary the different hyperparameters and then compare the ROC, compare the APC, compare your precision recall scores on their own. And this kind of helps you get a sense of the model. And this is important if you have different business goals. So sometimes it is more important to have a higher precision, and sometimes it's more important to have a higher recall. And none of these have a lot to do with accuracy of your model if you have an imbalanced data set. So you need to ensure that what sort of parameters, what sort of features is giving me a better precision, what's giving me a better recall. And based on what that business goal is, you should do that. You can use that version of the model that worked better for a metric. And you think when this can happen. So for example, let's take again the advertising experience. Sometimes it's important to generate clicks and conversion. So conversion is when you click on an ad and then go and buy the product. And sometimes you just want to increase your reach. You just want people to be aware. So you want them to see an ad. So that's more like impressions. So those are two different goals. When I'm optimizing for impressions, I just want to make sure the maximum number of people see it. If I'm optimizing for clicks and conversions, I'm personalizing it to the user, which also means I'm bidding higher for a certain user to go and click on that. So those goals can change, but the data itself doesn't change that much because I'm still tracking the same things. However, what I'm optimizing for, your loss function, the features that become important for one thing, that varies. And all of having the right monitoring in place will help you. Sorry. And then you also have model selection and service endpoint. So model selection is basically once you've deployed at certain models, and let's say we've trained a model and you had an older model that was live. Now, it might be that the older model was still performing better than the newer model, still had a better performance metric. And in that case, I don't actually want to deploy my new model. I'm quite happy with the older model. So having a model selection place is really important. And we used to do this a lot in advertising because it just worked better for certain advertisers. They didn't need a newer model, but it's still good to keep an eye on that. So we talked about concept drift, and I definitely want to just talk a little bit more on that. So concept drift, model decay, this is where model selection becomes quite important, as well as your model training, your model refresh. You want to make sure that you're obviously always monitoring what's happening to your data. A good example is, let's say, Netflix. one day I'm really interested in watching crime series and I just overdo it. I binge watch for 3 days and now I'm so over it that I can't ever watch crime series again. But for those days, like when I was Googling which was the best crime series, what should I watch, going through all of those things, Netflix thought that the best recommendation for me is crime. And then after a few days, suddenly I'm going more to Disney. And that confuses the model. And if that model hasn't been refreshed, then they don't know that. Similar issues for Spotify. And there are loads of papers on this, on how concept drift is such an important thing for them because your music tastes constantly change. It depends on your mood, depends on who you are with, and depends on what you're doing. Like I listen to different things when I'm running, whereas I listen to different things when I'm coding. So it's things that you have to understand the nature of your user's interests and then the model design based on that. So that's really what are the different components of machine learning. So as you can see, putting something in production is quite complicated. So then we can use workflows for this. And why machine learning workflows? This is becoming a really big topic these days, and you have so many different types of workflows out there. So which one should you use and why should you even use one? Can I just create my simple notebook and just have these functions that run it? Uh, it's just something that's easier and nicer to streamline your process in. So this is something I picked from Google Clouds, and I couldn't really make it better my way. So this is better because I would just make a mess. So I have the link from where this is. So really, it's quite clean. Source and prepare your data. This is what we talked about from the data and the feature preparation side. And then all of these can be just put into one sort of a container and the run scripts that basically fire up all these tasks that you need. You could have something like a tag like Airflow or something to basically schedule your train once you have the certain aspects of your data, your features all done and ready. And obviously you want some dashboard monitoring to ensure that it's healthy. Once you then initiate the train part, you can go into evaluation. Obviously, you would tune, you train and tune, and then you evaluate on your test set, and then you move on towards the deployment. So all of these things are just literally what we talked about, but you can basically stage them into various processes, stepwise processes, which you can monitor. And I'm saying stepwise, but a lot of those things could be things that run in parallel, and that depends on how you design and architect your workflow. And you could always use something like a MapReduce framework to initiate your feature processes that are independent to then run in parallel, and then eventually fire the next stage, which would be sequential. So those sort of optimizations are quite easy to do once you have this mapping done in front of you. These are some of the examples of workflows. So I'm using AWS SageMaker as an example here because it's a fully managed machine learning service. You can use it on its own, and you can also combine it with all of the things mentioned below. And it basically provides all of those components that we talked about. There are aspects which might make something like MLflow better, but I think as a starting point, if you're just getting into workflows, AWS SageMaker is really fun and easy to start with. And then MLflow, I find I use more for my own personal use cases. And because it's something I can easily run on my local machine. And if I need to scale, then I can easily combine it with SageMaker or GCP and have that integration. And they have plugins for that. So it's just a very small piece of code that you need to add to just fire up an EC2 machine, for example. And then, so in MLflow, the model tracking, that's kind of nice because it basically gives you all the models that you've run. And then you can basically select which ones you want to compare. And then you can compare the parameters, you can compare the performance metrics on its own as well as against each of those models. Sort of like a price comparison site where you basically look at different phones and you get this ran, this works on this. And you can have the same for your models. So I quite like that. Then you have Metaflow, which is, I think, by Netflix. And MLflow is by Databricks. So it works really well with Spark, which is useful if you are using Spark a lot in your organization. So Metaflow is another one. It's the same. It has a lot of work on data workflows as well as model management. This one is very closely integrated to AWS, whereas all the others, you can easily use them with other things. So I think it's like a small, slightly narrower use space. Now, Kubeflow, I don't know a lot about this one because it's more for ML on Kubernetes, which I haven't yet used or been in an organization that uses it. But from my understanding, it's more to do with having different containers. So Kubernetes is an open source platform for different containers, and you can basically have your ML workflows running in each of those containers, and you can integrate that with AWS to scale. The rest is Kedro, Airflow, Prefect, Dagster. These are all data workflows. And basically, I think other than Kedro, but Kedro has a plugin with Airflow, most of them can just work as a scheduler. So you can basically schedule each task to run after the other if it satisfies certain conditions or requirements. So Airflow is really something which I would go for if I just have a simple machine learning, sorry, if I just have a data pipeline running. And if I don't really have to do any sort of tracking around it, just run this, join to this database and ensure this is what that database is, and ensure that these many counts have been satisfied. So I have some simple tests and assert statements, and I can just run that with Airflow. Right. So I just want to go through what an AWS SageMaker workflow would look like with a real example. And this is just a life cycle, again, stolen from the SageMaker website because I can't draw. So this is all the different parts. You have the generate example data, they call it, but it's really more about your pre-processing and your feature transformations. And then you have your train model and your deploy model parts. I will briefly go through them, but a bit later. So this is what SageMaker provides you. The label part is something I'm less familiar with in SageMaker terminology, but what it really does is it provides you with different options on how you can generate labels. So one of the examples is in travel where you have a lot of images and you want to build a model that says this image is nicer than that other image. And this helps with ranking. And in that case, you want people to be able to you want enough data to do some sort of a deep learning model on an image. So then you can basically use Amazon Mechanical Turk, where people are given images and you have two images and you have to just select which one you like more. And that's sort of an example of this labeling, what that means. And you could do that for various data sets to generate different labels. Depending on your requirement, they will basically find SMEs if you need that for your model. So something like detecting like a fracture, you probably want someone who knows what a fracture is rather than just anybody can say which one's a beautiful image. So then moving on to then it's just really all the stages we talked about, which is the SageMaker Studio basically has just a nice interface where you can initiate your notebook, you initiate an instance to start your notebook. Then you have various models that you can do your training. And then you have your endpoints, which is where a user, if you're hosting like an endpoint is basically something like a user interface where your model is giving you predictions. So that's basically another machine because it needs to constantly run that server and you're pinging it with your model's results. So getting started, if you're new to AWS, it's really simple. Just create your AWS account. And then SageMaker instance types are slightly different. They're also called EC2 instance types, but they're optimized for ML algorithms. And obviously the type of instance is dependent on the region and availability zone. I've also attached the links for the type of instance and AWS regions. And I'm assuming that the slides will be shared with everyone. So hopefully you have the links. Yes, David says yes, so you should get them. All right, great. Now, so ML instance types. So these are basically the machine learning instance types that you can use. And the reason I put this here is because you don't always need to have a GPU for something to run. If you have a simple shallow network, you don't need that. And if you're running the non-deep learning models, if that's a better word for that, so you could use an ML M4 large. And that's really a good instance to start with. It's not free. So always be careful when you are starting things on the cloud. There are free tier ones and there's not. And when you start an instance that's running means billing. So when you're playing around with things, you should always remember to turn it off once you've stopped. A good instance to start deep learning with is a P2 large, and that should be sufficient for running things on something like a CIFAR data set. And you can pretty much run ResNets and things like that on that machine, and you should be good to go. The reason I put this here is because if you don't want to read the full boring documentation and you just want to start, then just use these machines. Right. Now, things to be aware of, quotas. So when you fire up one of those instances, you get the quota of 20 instances. Now, this might not always be the case depending on which region you are and the availability in that region. And if you want to increase your default quota, or if you feel that in your region, for let's say the MLT2 medium is 20, but you only get 10, you can write to AWS Support Center, and I've put the link where you should go and request that. And if you request it, it generally gets done in like less than 24 hours. Just another reminder, shut down your SageMaker instances. I'll repeat this multiple times because people tend to forget. Everything from a notebook instance to an endpoint to a model that's being trained is going to be charged. Right, so now back to our beautiful workflow. So the data generation process. Now we've spoken about all of these. I'm not going to spend too much time in it, but basically this is just your fetch data, clean and prepare transformation. A lot of this can just be done on a notebook instance that you can start in AWS. I'll just show you how to do that. But basically you could also have scripts or a jar file or a wheel file, whichever you're using, to then run these things as well. So notebook instance, very simple to start. Go to SageMaker and you'll see the notebook instance there. Want to go to create notebook instance, and really that's where you want to give the name, the instance type. So MLT2 medium is the free tier. So this is where you can go and do simple things like EDA, upload your data to a S3 bucket, and then just start running things on it. And this should be free of charge. You can even do like very basic, simple models, and it still can handle it. So this is where you should start experimenting with before you go and get things built. You have to select something which is called a role, so the IAM role. This is more relevant as you go into large organizations because you should have permissions for certain users. You can imagine in finance, that's a huge thing. People shouldn't have permissions to everybody's data. Only certain teams can have access to certain things. And obviously with GDPR and all those things, this becomes even more important. So setting the right IAM role for your organization is important. And if you are just doing this for fun, then just create a new role. If you have an S3 bucket, then this is where you would put it. If not, just select none and you get the default one. If you also have all your notebooks, that suppose you've run it on your local machine, or you have MLflow and those notebooks running through there, and you put that on GitHub, you can integrate your GitHub to your notebook instance. So you have all of your Python notebooks there, and then you can play around with that. Also your scripts, so anything. That's basically what your notebook instance would look like. So basic configuration to get you started on a very free tier. Right, instance creation. So once you do that, you just have to do, I want to create my notebook. And basically once it's in service, you can open Jupyter Lab. Again, this is just how you get clone your repository. One thing to remember when you do that, you have to CD into SageMaker. Otherwise, you won't find your repository and you wonder where it went. So you should always do it in SageMaker because that's the root directory set in there. SageMaker session and role. So this is us starting a container for AWS SageMaker, and basically it's very much like a TensorFlow session. So you're just telling it, this is my session, and all of the things that I do are going to be contained within that session. And also creating that role. So the IAM role, you're basically telling it that this is my execution role. So you'll have permissions to train your model on these data sets. Data processing. So I'm just using a very simple example of Boston Housing data set. I'm sure everyone is familiar with that one. And using sklearn's function call to get the load Boston data set. So once your train validation test sets have been created, they need to be stored on S3. And this is because SageMaker can only access S3 buckets to get that data. So just remember that you need to store it in there. And this is when you want to put good data practices, where you want to have a prefix that gives you the model name and version so that you have clean paths and you know how to track things. And then you can even go to the S3 service to ensure that you have your data there. So just select S3 from the services over here, and you have S3 in storage, and then you can basically look at your bucket that's been created. And if you click into that, you should see your train validation test data sets. One thing to remember, this is just a very simple example, so it can run even on my own local machine, but sometimes when you have terabytes of data and you're using like a MapReduce framework to read it, you don't want to write 1 terabyte file. You want to put that into smaller chunks so that your data, whoever is reading, like especially Spark is not that intelligent. It needs to have chunks so that it can read that and parallelize things properly. Otherwise, what you'll see is you're just using one machine out of your entire cluster, and that's basically going to try and read that 1 terabyte file, and then it will try to partition that, and that might even kill the full cluster, or it will just leave the rest of the machines not doing anything, and you're paying for that. So be careful about designing even your input source according to the architecture of your system. So the next part is more training. Now, training is really simple in SageMaker, and basically you create something that's called a training job. I'm using the inbuilt training model here. So each of the inbuilt libraries, if you must, like XGBoost model, they all have their own container. So you can find the container in the path at the bottom. But basically, you want to tell SageMaker session that I'm using this container, so please pull this model out. So that's the Docker path. And then you also give it the output S3 location as well as the resource. So what sort of resource do you need to run this model? So if a simple resource, if it's an XGBoost model, but for maybe a deep learning model, you need something bigger because you have a high dimensional feature space. So once you have your train job, you want to start what is called a model estimator, which is where you're giving all of these information. So if you look here, you have the XGBoost container. Now the container path can just be, can also be called with a function call, which is your get image URI, and you just tell it, I want the XGBoost path. The role is the IAM role. The train instance count, how many instances do I need to train this model, and what is the type of that instance? So MLM4 large, just because it's just an XGBoost model. Now the train job, obviously you want to set your hyperparameters, and they all have the default values, which you can go and look up in that link. But the ones that you want to set yourself or change the values of, you would set it in there. And there's also things, this is a very simple model, so I'm not doing a lot of cross-validation or any of those, but obviously you can do that, and you can set those as arrays and let it do the cross-validation for your data set. Now it's just really standard way. You want to call the fit method. You tell it this is my train path and this is my validation path. So then we come to model evaluation. Now, again, this is like a transformer object that basically will evaluate your model performance on. It's very much like the estimator object, and you need to tell it the same things like what is my instance count, what is my instance type, and then the location of the test set, the type of the test set. There is a split type, and the reason that's there is because you could have a huge data set, and that data set needs to be split into chunks. So the model can evaluate that in chunks, and that would be faster than doing it on one really huge file. And this basically just tells it how to split that data set. Transformer.wait is just like a nice to have because it kind of brings that ... where you know it's completed or not, because it runs in the backend. So otherwise you wouldn't know when it's finished. And that's basically it. So you have to remember, because we had loaded this on S3 for it to read. So in order for you to do your evaluation and plots, you want to pull out that data from where the predictions are written to your notebook's local machine, and then you can basically see your predictions. Now, this is if you're evaluating without deploying the model, but you also have the deployment stage. I know there's a lot, but the deployment stage is the last part. And once that's really what we want to know, is how can we deploy this? So deployment is simple. This is a high-level API, and there is also a low-level API where you can go into a lot more details on how you want to do that. So if you want to set up endpoints and have a web UI to go around it, then you can use that. So deploy is basically, again, a function call where you're, again, telling it what sort of instance type and how many of those that you need. And here we're asking SageMaker to start a compute instance, and this will be at the endpoint, and it's going to be constantly running till you go and shut that down. Because that's the whole point of having this deployed endpoint. You want the user to be able to interact with it whenever you need to. And again, it's quite similar to testing the deployed model. I've added concept drift here just because I think it's really important to constantly remember that. But again, it's quite similar to how we did the evaluation. You want to tell it the type of the data. You also want to serialize it. And that's basically predicting it. And yeah, it's not much very different. It's just a different syntax really, but it's kind of doing the same thing, except now you can deploy it to an endpoint. And that's your results again. So yeah, I think that's pretty much all of it. This is like a cleanup list remember, delete your endpoints, delete your endpoint configurations, your model, S3 buckets, stop the notebook instance if you're not using it. All of this is important if you're doing this for your own personal projects. Obviously, if you're part of an organization, this is something that should be taken care of. And if you're somebody who's running a team, then you make sure that you take care of that. Otherwise, that's going to be a very big bill. So I've attached some useful documentations. I also have a step-by-step blog here about the AWS SageMaker bits that goes through this. If MLflow is something you're interested in, then there's a meetup on Monday, which is going through that. And it will also be sharing things in a similar way where we'll run the code and see what that looks like with MLflow as well. But yeah, that's it. I hopefully am on time and so space for questions.
Thanks, Roshini. That's very nice talk. I really like how practical and real world it was, especially with some of the things to watch out for when we're doing machine learning production. Yeah, so we move on to some questions. We have a couple. So the top voted question from Cesar, Roshini, how would you compare the GCP, so Google Cloud AI platform, with SageMaker for ML workflows?
So I think with the AI platform, I think it's nicer if you can use your own workflows and then you integrate that with the AI platform and you can just use that to deploy. With SageMaker, you have all of that integrated into one service. I think I would still prefer to use the MLflow and the Google AI platform interface for me because it has more opportunities to adapt my code my way, whereas in SageMaker, you have to put a lot of effort to ensure that you're using different libraries because the SageMaker has its own syntax, which can sometimes be annoying. So you have to remember the estimator and all of those things. Whereas with the Google Cloud Platform, and has nothing to do with cloud, it's just the interface of it. It's much more easier and smoother. So personally, I actually would prefer to use GCP with MLflow.
All right, thank you. And so another question from Yadir. Um, so in opinion, how long does it usually take to get a good and reliable model into production? So that's from the first stage of data collection right on to deployment. How long does that take in experience?
So this really depends on the size and complexity of the organization more than anything. So having a good model, I feel isn't that hard, but getting the good data to run that model is a really hard part. So if you take a medium-sized company, I'd say you can actually have a good model running if you have access to all the data sources. And I would put in a lot of buffer time to fail. And then I would say like 6 months would be an end-to-end process. But if I put like a really huge company, like HSBC, for example, if it's a large scale project that goes across all of the 64 different countries that it's looking at, it can easily be more than a year to get all of that sorted because each one of them has their own way of writing that data. They have their own IDs. You have to consolidate that and then generate features and see if that makes sense, speak to SMEs in all of those countries. And it's huge. And it can get very complicated very quickly.
All right, thank you. That's very good and realistic so expectation to put. So there's a question from Umesh, and I guess since you were talking about concept drift, so how frequently, Roshini, do you in your experience revalidate models in production? And that's because data can be dynamically changing.
Yeah, so mostly it depends on the nature of what you're trying to optimize. So if I'm trying to look at recommendations on things that are user interests, like movies or songs, that can easily change quite often. But a good way to get an intuition here is not like what I feel like, it's more about what the data and distributions are telling me. So more scientific intuition, but look at the distribution of the various features that you're using. So let's say things around how many times does someone click on a particular genre, and then I would look at that number of clicks and build something like a time series to see how often on average does this change. And that sort of gives you an idea. Okay, generally on average people would click on a particular genre for these many months or these many days, and in that case you have to monitor and refresh your data that way. And then the other way to also look at that is to constantly have an idea of what your model's best performance is. And if that performance starts to dwindle and starts to go down, that's when you need to have some sort of an alert around that distribution. So let's say you have a ROC value of this much, or you have an average precision of your model, which is this much. And in that case, when once that starts to go down, that's when you want to understand why is my model decaying. And once your model decays, then that's when you want to refresh your data. So I would monitor both of those aspects. Initially look at the features to get an idea, this is how often I need to train, but then use a more quantifiable approach by looking at your model decay and then deciding when you want to retrain.
All right, thank you for highlighting the key monitoring features. There's another question from Radil about bad data. And so in your opinion, Roshini, what is the main cause of problems for machine learning production? Is it bad data in the sense bad quality or lack of it? Or rather, is it bad processes?
So you're always going to have bad data. That's not going to change. So it's really bad processes because of lack of monitoring and tracking. So I think you should always assume that your data is bad. That's just what I've learned, that everything is just not correct and has to be constantly looked at and tested for. So not enough testing and not enough tracking, in my opinion, is what would cause productions to fail. And also thinking that not paying enough attention to data quality is not that important as it is to model training, but I feel that data quality is more important than your model, because you can always have really good data and an average model can do well, but if you have really bad data, no matter how good your model is or how big your machine, it's not going to do well.
All right, let's see. So maybe we can take two more questions. Is that all right with you,
Yeah,
Roshini?
sure.
Oh, all right, cool. So there's a question from Rajat, and he's referring to the quotas on AWS that you had on the slides. So what is quotas? Is this the number of instances that you can spin up?
Yeah, so it is the number of instances that you can spin up, and that depends on the region you're in. So if you go to their website, that should have a link which tells you that if you're in this region, these are the number, this is the default, but in your region, these are the number of instances that you can spin up. And if you want to increase that, then you go and ask support to give you some more instances.
Okay, and last question from Medi. So he says, or she says, great presentation. And it's interesting to see how easy to build ML models with Python on AWS. So the question is, what about our users? Is that possible?
Ooh, I feel like I want to say yes, but this is not something that I've looked at because I don't use R. So I'm not going to say anything. I think these days R is being catered for by most workflows, but without going and looking it up, I'm not going to tell you something and then that turns out to be wrong. So yeah, I don't know who is the right answer.
All right, thank you, Roshini. So there are a lot more questions, but in the interest of time, I think we want to give thanks to Roshini for her presentation today and all the questions she's answered. If you have any sort of other questions, I think can find Roshini on her Twitter. So that's at Rosh_J. Is that right?
Yeah, let me just pull that up. Sorry, so many slides. Yeah.
So they have on the slides Twitter and also on LinkedIn. And you can find her on the Women's in Machine Learning and Data Science London group as well. So we just want to give thanks for everyone who joined today. And if you have any more questions, please ping her on the Slack or also on Twitter if that's all right. Thank you, Roshini.
Thank you so much. Bye, everyone.